Hello everyone, and today we will be seeing one of the problem from Geeks for Geeks. It says k-sized subarray maximum. The problem goes like, given an array ARR of positive integers and an integer k, you have to find a maximum value for each contiguous subarray of size k. Return an array of maximum values corresponding to each contiguous subarray. So that means we are given a value k along with this array. So if k is 3, that means among these 3, what is the maximum? So among these 3 is the maximum, so the answer is 3. For next, among these 3 again is the maximum, but among these 3, 4 is maximum, so 4 is the answer here. So on so forth, we complete the array, and the resultant array would be obviously this length minus k. So this is how the output should be generated. And similarly, we have second example which is quite similar. Now how do we approach this one? So naive approach or a simplest approach one can imagine is, hey, I'll consider this index, and here on I'll consider k elements, so 3, that means 3 elements, and I'll understand who is maximum among these 3. Whosoever maximum, I'll store it. Same, now I was earlier on 1, I will go to 2 and I'll consider next 3 elements, next 3 elements, next 3 elements, and so on. That would give you a time complexity of n into k, because for each element in each element of n, you're checking forward k times k further elements, so k times of n is n into k. So that is not what is expected from us. They are expecting O of n time complexity, and hence we have to have a better approach to solve this problem. So let's take this question or sample example and understand how we can solve this. So first of all we have such kind of example in front of us, and within this we have to solve for k is equal to 3. K equals to 3. I'll keep it up. Yep. How are we going to do this? So one thing is, we have two items, like we have to find maximum and we have to find till k. So I'm breaking these two things. So what I'm telling you guys is, hey, while searching for some elements, can I find maximum? Yes, I can find. So let's say I have iterated 1, I have iterated then 2, then 3. Till this point I know what is my maximum is 3. Next I'm coming up with 1. Then I have to choose between 3 and 1. Who is maximum? Choose between 3 and 1. Who is maximum? And whosoever maximum, I'll consider that. Or for a while I'll consider 3, 1. And I'll store the index as well for simplicity. 0, 1, 2, 3, 4 and 8. Yeah. So these are nothing but index, and these are nothing but values, actual values. Now we have 3 and 1, 3 from index 2 and 1 from index 3. Now we go next from this, we have 1 into consideration. Okay, we had already this, so the answer for these 3 you already know, man. The answer is 3. And now we have one element again, so we need to choose from 1, 3, 1, which is this section, what would be the answer. Before we go ahead and append the next element obviously would be 4, but prior to that, what is the answer of this? The answer would obviously be within this, choose between this whatever store we are storing. I have not fixed the data structure, but yeah, it will come soon. So within this, 3 is the maximum, because right now I have only 1 and 3. So 3 is the maximum, Next I'm coming up with 4. So I'm integrating 4 with me. What should I do? So I choose between, when I'm choosing 4 or considering 4, which is obviously at index 4 again coincidentally, what should I do? So 4 is obviously, first of all, this won't be in the picture, or would it be? Yeah, this would be in a picture, but again I have 4 here with me, which is with an index 4. Then shall I consider this too? No, I should not, because 4 is a maximum value and the 4 is the latest one. Why? Because I'm not considering them. Maybe instead of 2 over there, instead of this 2 over here, I have 200. But it doesn't matter. It doesn't matter because I'm considering this range, and the 2 is expired. So I have to consider 2 things. Find till k, that means consider expiry, and maximum means consider superiority. So these 2 things. So I am removing this and then adding this one. So on so forth, I can go beyond, add new elements and consider it into an array. Okay, right now I'm telling it array. I'm not sure what it is, by the way, but this obviously is a data structure which will be in the descending order. So it will be larger to smaller, and also it will consider the most likely dead or most likely to expire on the first side, and then you can see over here 2 is most likely to expire, index 2, than 3, then recently added. So you see, we can add a larger number right at here if we find any, so which we did with 4, or we can remove any from here itself, but we are adding 1 as well, so both side it's open. So that gives me 2 points, like hey, I can insert this way and I can insert this way, considering the data structure is like this. Again, I can remove all as well. When it comes to removal, I can remove from first and last, both. That is what dq does. Dq, nothing but double-ended queue, which serves this kind of purposes, where you wanted to remove or add either from either of the sides. So with that thought in our mind, let's get started with the code. Now they wanted some things from us. What are those? They wanted an array list to return. Cool, we will go ahead and return that for them. Return result, and this would be our answer. As I mentioned, we are going to use dq, and that would be integer. I'll tell that's q. But wait a second, what this q would consist? So this q can consist 2 things. Either it can consist value or index. Index makes much more sense because I can not only check the value anytime for superiority, but expiry also I can check with index. So to store index. Cool. Now I can store index as well. So I wanted to have my queue initially filled. How can I do it? So I can run a dummy loop or an initial filler loop, which would run till k elements. So initial process for first window, I'll say. Remember, we did the same thing for this one. We got a first window, we got the answer as 3. So within this first window, I'm not going to do anything because expiry doesn't count here. Only thing counts here is superiority. You'll say, why expiry doesn't count? Because wait a second, my loop is running only till k, so no of the elements can expire. So yeah, with that thing in mind, while I'm telling that queue is not empty, and when the queue is not empty, I wanted to consider whether the incoming element is greater than, then only I'll going to push it or insert it. If my existing element within the queue, which is queue dot peak last existing element, is lesser than or equal to a of I, then I am not going to insert this. I wanted to make space first of all. So because guess what, the lower elements are not used to me, same like the lower elements were not used to me when I saw 4, a kind of gold digger attitude. So q dot poll last, because last was less, so I don't want lesser elements, I want greater elements, and that's what I'm doing. Ultimately I will just fill the moment when this while loop breaks, I'll just insert the incoming I'll insert the element in the last which I have got from I. Cool. The moment I'm here, I know that my initial window is filled, this window is filled, and I wanted to store something into the result. So rest.add a of q dot peak first. Why peak first, I'm saying? And I'm removing from last, checking the first, because my larger element is first and then I have a smaller element. So while removing, I'm checking the smaller because I wanted to make space, and while showing, I'm showing the maximum out of me. So int I is equal to k, and what I'm doing here is check the rest, and I is less than k dot length I plus plus. Now with this thing in mind, I wanted to make space, something which we did earlier as well. We had earlier as well, make space. How do we make space? There are two things. There are two things that either expiry or superiority. So let's do one. I'll check expiry first. No matter, you can check any of the items first. I'm choosing expiry first. That's the only thing. While my queue should not be empty first of all, and I wanted to check that hey queue dot peak last. Again, why last? Okay, most likely to expire is on front. Sorry, my bad. Peak first, and my peak first, if it is lesser than or equal to I minus k, it will give me the expiry window, right? Correct. And for this items I wanted to remove because these are expired. So q dot poll first, because first I'm checking and first I'm removing, and just I wanted to make space. I've checked expiry, I'll check superiority. Checking superiority here, where first of all considering that queue should not be empty, then only I can check for with the elements. And q dot superiority, when it can break on some smaller elements. Where do I find smaller elements? On the last. So q dot poll last, sorry, peak last. I don't want to remove right now. Peak last. If this is lesser than or equal to a 5, the incoming one, then I wanted to remove this whole last. Cool. I have made space successfully. Now I want to insert this one, q dot offer first, offer last, because I know I have removed from last with the superiority, and I'm going to insert that one. The expiry doesn't count here because this is the latest element and this is not going to expire soon. So within the array or queue, the most likely to get expired is this current element for that instance. So offer last, and you can validate it because recently added is on the last, and smaller because I have removed all the elements lesser than me. So offer last is this current item I. And once I have this one, result.add q.peak first, and here I don't need to check whether the queue is empty or not, because hey, I'm adding it here itself, right? So yeah, this can be this is a working solution as for me. Let me compile this with sample test cases. Okay, there are few errors. What are those? Illegal start of expression. Okay, what's wrong here? Line number 31. Okay, what is illegal start? Yes, nothing also illegal start. Why it is giving an error? List integer array list. New array list. Oh, okay, my bad. Cannot find symbol DEQ. Okay, the spelling. Sorry, do not do such kind of mistakes. And still, it's an abstract class. Yeah, that is true. It's an abstract class, so I need to have linked list. Just very similar to Q. DQ is also a abstract class. Not again. What is wrong here? I'm getting this element first. It should not happen. Offer last, yeah. Am I not removing these things? Oh, okay. I'm not supposed to add index but values. Yeah, values should be the one. Okay, added the values. Let's try to submit this one. Yeah, it has submitted, and this was a good problem from which touched upon Qs and DQs. So this was a good problem as for me. I like this kind of problem, and yeah, this was all about it. For more such kind of content, click the video on your right, and I will see you in the next one. Yeah, also one last thing. The time complexity and space complexity of this is, space you directly know, O of k, but time complexity of this algorithm is O of n. Why? Because do not consider that we are using two loops, so it would go multiplication, but it doesn't multiply. Consider into this way, that consider a queue, and for each element, n elements, either it can go within a queue once and leave the queue once. So within a queue it's going once. Let's consider it takes a complexity of O of n, and leaving a queue takes O of n as well. So O of n plus n is O of n only. So the time complexity is O of n itself, and not O of n into k. And this is in case in turn an optimal solution. This is very similar to find the area under the histogram. If you are unaware of this, click the video on your right, and I'll see you in the next one.